Sound check, sound check. Integrated Math 3, this is your assignment for the new unit, Unit 2, which is called Polynomials. This is the first lesson, 2.01. There is an instructional video that goes with this on PowerPoint. And so I'm going to do some of the problems here, not all of them. I'll leave a number of them for you to do yourself, but they'll all be similar to the ones that I do. So let's go ahead and get started with this. So, okay, so what is a polynomial? A polynomial means many terms. So let's define what a term is. And this is in the instructional video, by the way, these explanations. But a term can have up to 3 parts here. It has what's called a coefficient. That's the number in front. A variable. That's the letter. And an exponent. So it has 3 parts to this term. This term has a coefficient and a variable. You don't see an exponent, but when you don't see an exponent on the variable, you assume it's implied that it's 1. Okay? This is also a term. It doesn't have a variable and it doesn't have an exponent. It just has what we call the coefficient. We would just call that a constant number, because that can't vary, it can't change. This one is a term. It has a coefficient, a variable, and an exponent. This one is a term. It has a coefficient, which implied is there's a 1 there. Okay, so with the minus sign it would be -1, but it just, there's an implied 1 there when you don't see anything, and there's an implied 1. Implied means you assume it's there even though you don't see it. There's an exponent of 1 there as well. So even though you don't see a coefficient and exponent, it has one. And then here's a constant. And even that has a variable and a exponent. Let me show you how that would be. One thing to remember is that any number raised to the 0 power equals 1. So if I take x, raise it to the 0 power, that equals 1. Any number would. 2 to the 0 power would be 1. 1,000 raised to the 0 power would be 1. It's just the definition from mathematics. So if I were to call this 8x squared and this is x to the first, I could call this 6x to the 0 power. Since x to the 0 power equals 1, that would be equivalent to 6 times 1, which would equal 6. So you can think of that as 6 times x raised to the 0 power. So x to the second power, x to the first power, x to the 0 power. We're not going to get into that. I mean, you could just say there's no variable, there's no exponent there, though. Okay. So when you add these, you can only add terms You can only add terms if the variable and exponent are the same. So an x squared and this term x squared can be added. But the x squared and this term x cannot be added. Or the 4x and the 6 cannot be added. So what you should do is find the term in either of these polynomials that has the largest exponent. And that would be x squared. This also has an x squared. So you're going to make columns for each of the x to whatever power it is. So I'm going to start with x squared. That's the biggest. The next column is going to be x. And the next column, you could call it x to the 0, but we're just going to call it constant. Okay? So these are just columns to keep us organized. So now I'm going to write this polynomial under the x squared. The 3x squared goes under the x squared. The 4x goes under the x, so it's minus 4x. And the minus 1 goes here. Now we're going to add these. We're adding these, this right here. And then under the x squared column, you put 8x squared minus x. you want to write minus 1x, you can, just to remind you that you are doing a subtraction of 4 minus 1. And then over here is plus 6. Okay, and now we simply add. Negative 1 plus 6 is positive 5. Negative 4 minus 1, so you go in the negative direction 1, so it's 5x. And here you have 3x squared, 8x squared is 11x squared. Okay, so you don't change the variable or the exponent ever in an addition, but you just, the only thing that can change is the coefficients of each of these or the constants. Okay, so that's the answer for that one. Okay, all right, let's do the next one. Tell you what, I'm going to skip to 3. Let's do a subtraction. Since we just did an addition, let's do a subtraction. And it's the same principle. You've got to, you should make up columns. You can only add it if the variable and the exponent are the same. Subtraction adds just one little twist, and I'll show you what that is. So I'm going to make my columns here. The largest exponent I see is x to the third. This one doesn't have an x to the third, but the largest one of either of these is the x to the third. So I'm going to make an x to the third column, an x squared column, okay, like that. So let's go ahead and write this one first. You have to put these in order because this minus this is not the same as this minus this. So you have to put them in the proper order. So this one's going to go on top. So there is no x to the third term in this one, so you leave this blank. If you want, I'll just lightly draw a little circle showing I'm leaving it blank, okay? Don't have to do that. But the 4x squared goes in the x squared column, minus x goes in the x column, and then the 7 goes in the constant column. Okay, and we come over here, and we have 2x to the third, so that's going to come over here. Now, here's what you want to do. Before you do this, you want to turn this into an addition problem, okay? Let's turn it. How do we do that? We change all of the signs. This negative sign distributes throughout this entire parenthesis. So all of the signs flip. So this becomes negative 2x to the third. This becomes negative 6x squared. And this becomes plus 11, positive 11. So I'll write that up above without the parentheses. So if you do that, you don't write the parentheses anymore. Okay, so just understand what I did. I basically, this is a negative 1. You can think of that as a negative 1. You multiply negative 1 by everything in here, it just changes the sign in front of them. So that's a negative 2x to the third minus 6x squared plus 11. Now we've turned it into an addition problem, okay, by doing that. We've taken that negative sign out, and we've changed it effectively to a plus sign. We've taken that and attached it to each of these. Now it's a plus sign. So I'm going to come over here and put a plus sign over here. Okay, and now I'm going to write these. I'm done with this. Okay, I'm even going to put a line through that. I'm done with that. I don't want to deal with that anymore. I want to deal with plus this. Okay, so we come over here. So we have the minus. So it's plus negative 2x to the third minus 6x squared. Okay, there is no x term in this one. So we're going to leave that blank like that. I'm going to draw a little circle there. Nothing goes there. And then it's plus 11. And now you add. It just becomes like the problem above. So negative 7 plus 11 gives you positive 4. There's nothing here. It's a 0. So negative x plus 0 is negative x. 4 minus 6x is going to give you negative 2x squared. It's going to give you negative 2x squared. And then 0 plus 2x to the third is going to give you, or negative 2x to the third is going to give you negative 2x to the third. Okay, and that's the final answer. So let's review that. When you have a subtraction like that, distribute the negative sign through to everything. That gets rid of the parentheses, and then that negative becomes a plus sign, okay? You've turned it into an addition of these things. That's the same as a subtraction of these things. Okay, so then you've turned it into plus this, Now you can write all that down here, and with a plus sign it becomes an addition problem. And that I find is the easiest way to do it, so you don't trip over your negative signs. Otherwise it's easy to mess up negative signs like that. Okay, so that's the answer to 3. Now let's go back to 2. It's a multiplication, so it's a different technique we're going to use. Alright, so you're multiplying a 3-term polynomial. 1, 2, 3 terms. 1, 2, 2 3-term polynomials. 1, 2, 3 terms. Okay, so how do you do that? The best way to do these is to make a grid. It doesn't matter which one you put on. You're going to have a vertical axis, a horizontal axis, and a vertical axis. It doesn't matter which one you put on which. It's all going to come out the same. I'm going to do it over here because I have a little more space. So I'm going to write 6x squared minus x minus 4. And then down on this side, I'm going to write this one, 2x squared plus 5x. You don't have to write the plus sign. Here you want to, because you want to be sure. Well, you want to be sure that you don't get those put together. But minus 5, you can do it if you want. So there's a minus 5. If you want, you could go ahead and put the plus signs there. Okay, just to emphasize they're all positive. All right, and I'm just going to make, you don't have to draw lines, but it's sometimes helpful to keep things straight. So, like that, and like that. And I'm going to go ahead and make it into a true grid here with all the lines. Hopefully they're reasonably straight. Okay. Now it doesn't even matter what order you do it in. You got to multiply each of these terms by each of these terms, and you're going to end up with 9 different answers here, okay? So this time you can multiply if the variable, there's only one variable, it's x. But if the exponents are different, like x squared here and x to the first here, you can multiply those. Okay, so first they multiply the coefficients. So it's 2 times 6, positive. So that's going to be a 12. And x squared times x squared. So again, let's remember principles. Let's write these over here. X squared times x squared equals x to the 2 plus 2, which equals x to the 4th. Okay, you add the exponents. When you have two variables with exponents being multiplied, they have to be the same variable. That does have to be the same. Then you add the exponents like that. Okay, so that's going to be x to the 4th. Okay, now let's move over to this one. 2 times negative 1 is going to be negative 2. And here we have x squared times x to the 1st. Let's do that over here. X squared times x to the 1st equals x to the 2 plus 1, which equals x to the 3rd power. Okay, so that's going to be x to the 3rd. All right, 2 times negative 4 is negative 8. And you don't have any x term here, so it's just going to be this one, x squared. Okay, next row. This is a good practice at multiplying variables and exponents here. 5 times 6 is 30. And x times x squared, we already did that one right here. That's going to be x to the 3rd. 5 times negative 1 is negative 5. And x times x is x squared. That's x to the 1st. X to the 1st is x to the 1 plus 1 is x squared. And finally, 5x times negative 4. 5 times negative 4 is negative 20. And again, there's no x there, so this x is the only thing that will appear as x. Next one, negative 5 times 6 is negative 30. There's no variable here, but it's just the x squared right there. Negative 5 times negative 1 is positive 5. and it's just the x right there. There's no x there. And finally, negative 5 times negative 4 is positive 20. Okay, at this point, there may appear to be a pattern. You'll see all the x to the fourths. The only one is right there. The x to the thirds are right there. You can draw a diagonal line. And x squareds are right there. The x's are right there. And the one with no variable is there. You might assume that always is true, that you'll have these nice diagonal patterns, but you don't. So what you have to do is go around and just look for any that has the same exponent. So the only one with an x to the fourth is this one right here. So we're going to go ahead, and you always want to write with the biggest exponent on the left. That's called standard form. So the biggest exponent on the left, so that's going to be 12x to the fourth. Now we can come down and look for x to the thirds, and it's these two right here. So it's 30 minus 2 is 28, and then the x to the third stays the same. Whenever you add or subtract, you don't change the exponent or the variable. So it's 30 minus 2 is 28. So it's plus 28 x to the third. By the way, one thing I sometimes do is I go through and I x them out as I do them to be sure I haven't missed anything. Now we have 3. Negative 30 minus 5 is negative 35. Minus 8 more is negative 43. Don't try to do that in your head. If you're not real comfortable with it, just go to calculator. So that's going to be minus 43. And again, addition, subtraction, you don't change the variable or the exponent. They're all x squareds. Okay, so I've taken care of these. Now these two. It's negative 20 plus 5. That's going to get you to negative 15. And it's x. And finally, and I've done those, and finally the last term is plus 20. And I've covered everything. And there's your final answer in standard form. So largest exponent, then the next one, then the next one, then the next one, then the next one, standard form. I'll write that down. And generally you write answers for polynomials in standard form. Okay, that takes care of that. Let's keep going here. Okay, so at every point, try to do these on your own. Here's another subtraction, so it's good to practice those. Here's another subtraction. I'm going to do this one. You're going to do this one on your own. So first thing I'm going to do is I look for the largest exponent, and it's this x to the third. So I'm going to make my columns. Okay, x to the third. And go ahead and do that again. That's just to keep you organized here. Now I'm going to do with the negative sign what I did last time. I'm going to distribute it through here, and that simply changes all the signs here. So it's going to become negative 10. By the way, you notice that this one is not in standard form. That's okay, because you're going to place these wherever they go in the appropriate column. But this is an example of writing a polynomial that's not in standard form. So anyway, negative 10, and then it's going to flip this sign. It's going to be minus 8x, and then it's going to flip this sign, and it's going to be minus 3x to the third. And then that changes this into a plus sign. So it's this plus this. And you kind of forget about that. You don't use that. Don't get confused with that anymore. Okay, let's go ahead and place the numbers. So I have an x to the third, 7x to the third. And then I have a 3x squared plus 3x squared plus 4x plus 10. And then over here, I have a negative 3x to the third, so even though this wasn't written in standard form, it doesn't matter. I'm still going to put it in the x to the third column. Okay, I don't have any x squared term, so I'm going to just draw my little light circle. You don't have to do that, just leave it blank. Then I have minus 8x is in the x column. And finally, minus 10 is in the constant column. Okay, and now we add. So now it's an addition problem, not a subtraction problem. Once you change those signs, it becomes an addition. So 10 minus 10 is 0. You don't have to write anything there. 4 minus 8 is going to be negative 4x. 3x squared plus, and really this was 4x plus negative 8x, but I just said minus 8. So it's not a subtraction problem, it's an addition problem. Then I have 3x squared plus 0 is 3x squared. And then 7x to the third minus 3x to the third is 4x to the third, and there should be a plus sign there. Okay, and that's your final answer right there. By the way, you leave it like that. You don't have to factor the x out. Some of you may have noticed, hey, I could factor an x out. No, we're not doing factoring here. Okay, we're just doing additions, subtractions. Okay, so now that you're a champ at doing subtractions, do this one. This is a U problem. I'm going to leave that for you to do. Okay. All right, let's keep going. Okay, this one just adds a slight complication in that you have to distribute a number through this polynomial. Since there's two terms, it's called a binomial. Bi means two. So you distribute 3 through this, and then you distribute the negative 5 through this, and change it to a plus sign like we did before. So in other words, it's not just a negative 1, not just a negative sign, it's now 5 times that. So let's go ahead and do that. So I'm going to write this as 3c minus 12. 3 times c is 3c. 3 times negative 4 is negative 12. Okay, now what I'm going to do is minus 5 times c squared is minus 5c squared. Minus 5 times plus 4c is minus 20c. And minus 5 times negative 8, negative 5, negative 8 is going to be positive. Negative is a positive, 40. Okay? And so what I've effectively done in doing that is I've taken the parentheses away. So I have minus 5c squared, minus 4c, or minus 20c rather, and then plus 40. So really you're ready to go with this. And what you can do at this point with this one is you don't have to line up the columns. I could, and maybe I'll do it that way too. But all I have is a c squared term, so I'm going to write that down here, minus 5c squared. You have 3c minus 20c, so minus 20 plus 3 is minus 17c. Again, use a calculator if you need to on these. And then minus 12 plus 40, or 40 minus 12 is an easier way to think of that, is plus 28. Okay, and that's your answer. Now you say, wait, that was kind of different than the way you did it before. So let me do it the way I did it before. So this is going to still stay 3c minus 12. I'm going to leave that like that. Okay, now what I'm going to do is I am going to multiply. So I'm going to come over here. And again, the biggest term I have is a c squared. So I'm going to write c squared, c, and then constant. I better write const, because so you know the difference between c and constant. So there's the constant. That's the one we've been using before for calling it c. Okay, so for this one, okay, so I'm going to multiply negative 5 times c squared. So I'm going to separate these. Negative 5c squared, and then you have negative 20c, and then you have positive 40. Okay, so now I'm going to come over and place these. The 3c goes here, and then the constant is the minus 12. And now now I've changed this minus to a plus. So now we're done with this, and we're done with the minus sign. It's now this plus. I'll change that to a plus sign. It's this plus all of this. Okay, so now it's minus 5c squared, minus 20c, plus 40. Okay, So, and this is a plus sign here for all of this. So 0 plus negative 5c squared is negative 5c squared. 3 minus 20 is minus 17c. And negative 1240 is plus 28. So either way you do it, you get the same answer, okay? And I just wanted to show it to you the way that I did the previous two. Okay, this is a FOIL problem. FOIL stands for first, outer, inner, and last. FOIL, FOIL. Okay, so what you do, and you do use this with binomials. You can use it with the multiplication we did earlier with two trinomials, two polynomials. That's messy. It's messy to do it that way. So I recommend that one you do with a grid. This one's simple enough you don't have to use the grid. If you wanted to, you could write this, x plus 3, and over here write x minus 12 and I didn't make that space very big, but I can multiply this times this, get this times this for this times this for this, and this times this for this, and then add them the way we did earlier. But this is simple enough that you don't need to do that. So you do a first. That's the x times the x. So x times x is x squared. The next is the outer. That's x times negative 12. So that's negative 12x. The next is the inner. That's 3 times x is plus 3x. And the next is the last. And that's the 3 times negative 12 is negative 36. Okay, so you have 4 terms here, and the only two that have common variable exponent are the two middle ones. They are x. So you can put those two together. So the x squared stays as x squared. Minus 12 plus 3 gets you to negative 9x. And then the 36 stays the same, 36. So that's the final answer. If I had done it this way, I would have had x squared. X times 3 is 3x. Negative 12 times x is negative 12x. And negative 12 times 3 is negative 36. Again, the x squared and the 36 are what they are. They can't be added to anything. 3 minus 12x is negative 9x. You add those two, you'd get that. You get the same answer either way. Okay? But generally, you just FOIL it if it's binomials. Bi means 2. 1, 2. 1, 2. If it's two binomials, just FOIL it out. Okay. So this one I would use the grid on, and we're going to do this. So first you have 3 multiplications. First you have this, and then you multiplied by this, multiplied by this. Now let me tell you, it doesn't matter whether you're going to distribute this 2 in here. You could also distribute it in here. Multiplication is completely commutative. You can switch it around. In other words, A times B times C is the same as B times A times C is the same as C times B times A. You can do them in any order. So I can multiply the 2 by all of this and then multiply by this. But since this is simpler and it's closer, I'm going to do this. So this is going to become 2y, and 2 times negative 7 is negative 14. I'm going to put that in parentheses. Now I still have this. You don't multiply the 2 through here and then multiply it through there again. That would be multiplying it twice. That's not good. You don't want to do that. So over here I still have what I have over here. What you could have done is what I just said. You could have taken the 2 and made it 2y squared minus 4y plus 16. You could have multiplied the 2 through this and left this guy alone. But I decided to multiply the 2 through this one. Okay, so now I have this instead of these two. These two become that. And then this stays what it is. Now I'm ready to set up a grid. I would do a grid anytime you have 3 terms, okay? So we're going to do, I put over here, I'll put the 2y and the negative 14. And up here I'll put y squared minus 2y plus 8. And go ahead and draw the grid. Okay, and so we've got, let me go ahead and draw another line down here. Okay, so we got 1, 2, 3, 4, 5, 6 boxes to fill in. So 2 times 1 is 2. Y times y squared, that's y to the first. Again, let's write it down. Y to the first times y squared equals y to the 1 plus 2, which equals y to the third. Okay, so this is going to be y to the third. 2 times negative 2 is negative 4. Y times y is y squared. 2 times 8 is 16. And the y is the only one there, so that's a y. Negative 14, there's no y there. Y squared is negative 14y squared. Negative 14 times negative 2 is positive 28. And nothing there, but there's a y there, so I put a y there. Negative 14 times 8 is going to be negative 80, negative 112. Again, use a calculator. Don't try to do stuff in your head if you're not comfortable with it. Okay? Okay, so there we go. I filled in all the grids. These are not part of it. There's nothing down here. Okay, so what do? We got a y to the third and only 1. So this one right here is going to be 2y to the third. I'm going to cross it out because I've used it. Then we have a y squared, so it's negative 4 minus 14 is negative 18, y squared. So we've taken care of that and that. Now we have 28 plus 16 is 44, so it's plus 44y. Those both are y's. And the last one has no y to it, it's minus 112. And that's your answer. Okay? These aren't really that hard. You just got to practice a few of them, you'll be good at them. Okay. This is explained in the video, the instruction video, and I'll explain it again here. This is binomial theorem. It's called Pascal's triangle. You don't need to remember that name. And it's actually, you could memorize how to do this in about 3 minutes. Seriously. First thing you do is you draw a couple of diagonals of 1s, and you can actually just start with the first couple. A 1 and a 1 there, and a 1 and 1. So you have a little triangle of a 1, okay? What you then do is you add these two together, 1 plus 1, and that gives you 2 right there. Now you continue to draw a 1 down diagonally like that, and another 1 diagonally like that. So you have 1, 2, 1. Okay, so now 1 plus 2, and you can actually draw another 1 down there. You can continue to draw them down, but 1 plus 2 equals 3, 2 plus 1 equals 3. So now you have 1, 3, 3, 1. Okay, now you draw another 1 down here and another 1 down here. And you have 1 plus 3 equals 4, 3 plus 1 equals 4, and 3 plus 3 equals 6. So you see the pattern that's coming on here. The only thing you got to do, keep doing, is keep drawing the 1s down here and another 1 down here. So 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then you've got the 1. You always have a 1 at both ends, okay? And the triangle starts getting wider and wider, and you can see the pattern. This actually has a lot of uses in math, but the one we're going to use it for is you see up above. If you want to take a binomial and raise it to a power, this would take a lot of work. This a plus b to the 5th, and this is done on the instructional video. What this is, think about that. It's a plus b times a plus b So that's this. So you'd have to FOIL this. You can't do all this at one time. You have to do it 2 at a time. So a plus b times a plus b, you'd have to FOIL it. In other words, first, outer, inner, last. And you'd get something. Then you'd have to take that and multiply it by this. And at that point, you'd have a trinomial here. So you'd probably want to use the grid. that we showed you, and you'd come up with something else. And then you'd have to multiply that by this, and then you'd have to multiply that. It's a big mess. Okay? But Pascal figured out, and they figured out that what you can do is whatever your a variable is and your b variable, and your b might not be a variable. It might be a plus 2, for example. It might be a number. It might be a constant, because usually that last term in any polynomial is a constant. So it could be a plus 2, for example. So anywhere you see a b here, it would be a 2, whereas the a would be a variable. But you can actually, what that would come out to be if you did all those multiplications is this right here. This is the ab to the 5th, and that's what I was doing right here. I'm multiplying it together 5 times. It's not 5 times. You're multiplying it this times this times this times this times this 5 times, and that is going to give you this. Now, what do you notice about this? If you come down, take this, and you come down to this row right here, look at the coefficients. Coefficient is 1. You don't write it, but it's 1. 5, 10, 10, 5, 1. That row right there. 1, 5, 10, 10, 5, 1. So what you can call this is the 0 row. Call this the 1 row. Call this one the 2 row. This one right here. Call this one right here the 3 row. The 4 row. You notice how the number here is the same as the first number inside of the 1 right there, and this one's the 5 row. So that is if you raised ab to the 5th power, the coefficients would be these right here. Okay? And that's what that's saying. So you'll notice that pattern. Here's another pattern to notice. So you can actually do these from memory. Look at the a's and the b's. For the a, you start on the left side, it's a to the 5th, then a to the 4th, then a to the 3rd, then a to the 2nd, then a to the 1st, and then remember we said you could call that a to the 0, which is equal to 1, so 1 times b to the 5th would just be b to the 5th. Or you can just say it disappears, if that's easier to think of, just the a disappears. With the b, it goes in the other direction. b to the 5th, b to the 4th, b to the 3rd, b to the 2nd, b to the 1st, and if you want to say it, b to the 0, or the b just disappears. So not only does it give you a pattern for the coefficients, but you can easily remember what the variables are with just practicing it a few times. You're not being asked to memorize this in this class. In a regular class, you might be asked to memorize it, okay? So anyway, that's how you do these. And so we'll do a few of them. And here you notice, I'm going to go ahead and do number 11 and 12. So here's 11. So notice the a is actually a variable, it's x, and the b is a negative 3. So that's what you have to be careful of. The b is not just 3, it's negative 3, because remember that pattern is it's for a plus b. So in other words, what you would call this is a plus negative 3. And then put another set of parentheses and it's squared. Okay, so this is your a is your x, and your b is negative 3, the entire negative 3, okay? All right, and that's squared. Now, for this one, we can just FOIL it, but we know how to do that. Let's go ahead and use this. So we're going to come down to the 2 row here, and it's 1, 2, 1. So those are the coefficients. And we know the a starts off with a squared, and then it has an a, and then it has an a to the 0. Okay, we said that. So let's look up here. A squared, let's go to this one up here. A, and then there's no a. And in front of the a is a 2. And I'm going to go ahead and write the coefficient 1 here and 1 over here. Over here is going to be a b squared, and then a b, and then no b. Okay, so we have a positive a squared. Remember that the b is a negative 3 though, so now we're going to do a substitution. Wherever we see b, we're going to put a negative 3. So it's 1a squared, I'll write it a little bigger here, minus, now negative 3 times 2 is negative 6, okay? So I took my b, which is negative 3, that's negative 3, multiplied it by the 2 there, gives us negative 6. And then the a. The a still stays a. That's a variable. You can't change that. And then finally, b squared. It's 1 times b squared, but that's just b squared. Okay, and I should have put plus signs in between these, but that turned into a negative because of the negative 3. B squared, now b is negative 3. Negative 3 squared is positive 9. So it's plus 9. Okay, and so you can take the 1 off if you want and just call it a squared minus 6a plus 9. Let's prove that. Let's FOIL it here. Oh, and the a's should be x's. Sorry, I changed it. They should be x's. So let me just go ahead and change that, okay? I was using the a's and b's from the general equation back there, but it should be x squared minus 6x. Let's go ahead and FOIL this now, okay? So it's x minus 3 times x minus 3. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is also negative 3x. And negative 3 is positive 9. These two you can add together. Negative 3x is negative 6x. Then the plus 9 stays and the x squared stays. So you get the same answer either way. For this one, it would be easier just to FOIL it. But with the longer ones, the next one, for example, it's easier to use the triangle. So I'm going to show it to you, but eventually you can do these by memory. So I have an n, and this is going to be n plus 4 to the 3rd power. Okay? So if I come to Pascal's triangle, I go to the row that has the 3 in the 2nd position. That's this. That's the 3 row. 1, 3, 3, 1. Okay? So I'm going to come down here and write 1, 3, 3, 1. Those are my coefficients. Now I start over on this side, and it's going to be n to the 3rd power, n to the 2nd power, n to the 1st power, and then no n at all. Okay, now your b here is 4. That's the b. So you come over here and it's, let's look at this here. It's b to the 3rd, b to the 2nd, b, and no b at all. So b to the 3rd is going to be 4 to the 3rd power. That's what b equals. That's the a and that's the b. This one, I didn't really give myself enough space here. This one's going to be b, which is 4 to the 2nd power. Put a plus sign right there. Again, that's b to the 2nd. That's there right there. B to the, b to the 2nd power is right there, and b is 4. So I'm not going to, I'll finish it in the next step. Okay, next one is b, so that's 4 right here. So that's right here, that's the b is 4. So b to the 3rd, 4 to the 3rd, b to the 2nd, 4 squared, b, just 4, and then there's no b there. So now I'm ready to come down here and simplify it. 1 n to the 3rd is n to the 3rd. This is 4 times 3 is 12. So you can combine those two and make it 12, plus 12. And then you still have the n squared. Now you have 4 squared is 16 times 3. Again, do this on a calculator. Don't try to do it in your head if you're not comfortable with it. 16 times 3 is 48. And then I have the n right there. And finally, the last term doesn't have any n. It's 4 to the 3rd. That's 4 times 4 times 4. That's 64. Okay, and that's your final answer. So that's easier than doing a FOIL and then having to do another multiplication after that. Okay, so let's do that again. We saw it's x to the 3rd, so we come up here to the number 3 row. That's this one. It's the one, the row number is whatever the second number in the row is. They're always, the first number is always a 1. In this case, it's 3. That's the 3 row. So the coefficients for the final answer are going to be 1, 3, 3, 1. So there it is, 1, 3, 3, 1. Okay? Then the first part of the binomial, the n, you start off on the left with n raised to whatever that power is right there, to the third. Then you just decrease it by 1. N to the second, n to the first, and then no n at all. For the second part, that's the b part. In this case, it's an actual number. You start on the right side, and it's that number 4 raised to that power, 4 to the third, 4 to the second, 4 to the first, and then no 4 at all. Now you're ready to simplify. You can get rid of the 1 there, just make it n to the third. 4 times 3 is 12, and then the n squared stays. 4 squared is 16 times 3 is 48, and then the n stays. And then 4 to the third is 64, there is no n. And that's it. It's in standard form, biggest exponent to smallest, right there. Okay? All right. I'm going to leave number 13 for you to do. That's a you problem. And I'm going to leave number 14. Oh, goody. It's an x, let me show it to you here. It's an x to the third. So your a is going to be a, and your b is going to be 3. Okay? So you're going to use row number 5 here. Okay, you're going to use row number 5 and put that together. Okay, that's a lot of stuff to piece together. Go ahead and do that, all right? Okay. Finally, they give you just kind of a puzzle problem. You got to figure out some dimensions. So perimeter is distance around. Let's define that. And area is the space inside. It's all of that, right? You know what area is. Okay, so how do you piece this together? Well, there's different ways. There's different approaches to doing this problem. One thing we could do is, let me just show you a couple of them. I'll do it what I think is the easiest. You can treat this like 2 rectangles. Just draw a line right there. So the area of a rectangle equals the length, and you can call whichever one you want the length, times the width. Okay? So the area of this rectangle right here, just this part of it, is the length. Let's call this the width and the length. So it's this times this. That'll give you the area inside this rectangle. The area inside this rectangle will be the length, this distance right here, times the width, this distance right here. And that'll give you the area here. If you have the area here and the area here, you add those together, and that'll give you the total area inside here. So that's the easiest way to approach this problem. You can do it, there's a way of doing it by subtraction, but it's messy. You would figure out the area of this entire rectangle and then subtract out this part that's not a part of that rectangle. In some problems, that's the easiest way to do the problem, not this one though. This one, the easiest way is to take it as 2 rectangles, rectangle, rectangle, figure out areas, add them together. Now perimeter is simply the distance all the way around. So the only sides we don't know are this side right here, this side right here, and this side right here. So we have to figure those out. Once we figure those out, we can add them all together. Now let's see if there's an easier way to do it. Well, yeah, there is. We know that what is this unknown side? Let's take this one first. It's going to be this side plus this side. So if I get this side, even though these two are not connected to each other, you say they're in different places, that's okay, doesn't matter. This distance plus this distance is the same as this distance. So just be sure you're comfortable with that fact. So what I can do is change this down here to x squared plus 1. I'll put it in parentheses, plus this side, 2x plus 2. That's this side, okay? So now we're figuring out the perimeter, the distance all the way around. So now there's only one side we don't know, and that's this side. See if you can figure out how you would get that side. Okay, so I'm going to tell you here. You can stop the video. Remember, you can always stop the video and think about things. If I take this entire side and subtract from it this side right here, just this side, that will give me this side. Because this side plus this side together have to equal this. So this side plus this side equals this. So that means this minus this is going to give us that right there. Okay, so I'm going to come over here and I'm going to come up here and call it this. It's this 2x squared plus 3x minus 5, and I'll wrap that in parentheses, minus this x squared plus 2x minus 2. Okay, so now you have a polynomial addition, two binomials there. You can call binomials polynomials, it's okay. And there you have a polynomial subtraction. So we've done both of those things before. Okay, so this is going to take a little work. So let's start with figuring out this area. We're going to do the area part of it first. It wants both perimeter and area. So we're going to do this first. So for this, I'm going to come over here. It's going to be 2x, 2, and then down here, up here, I'm going to write x squared. I'm making a grid. I should have told you that. Plus 2x minus 2. And I'm just going to freehand these lines right here. Okay. Okay, so here we go. So I'll do this a little faster because you've seen all this done before. So 2x times x squared is 2x to the third. 1 plus 2 is 3. 2x plus 2x, or 2x times 2x, sorry, is 4x squared. 2x times negative 2, 2 times negative 2 is negative 4, and then you got just the x there. Come down here. 2 times x squared is 2x squared. 2 times 2 is 4, and then you got the x, 4x. And 2 times negative 2 is negative 4. So I've got an x to the third term, 2x to the third. I've got, I've crossed that out. I got 4x squared, 2x squared is 6x squared. You're adding them now. Cross those out. You got 4x minus 4x goes away, it's 0. Cross those out, and minus 4. So there, this is that area, 2x to the third plus 6x squared minus 4. Okay, so now you've taken care of this rectangle, as you call it. Now we got to do the same thing. I'm going to draw a heavy line here to divide them. You got to do the same thing with this and this. So I'm going to come up here, I'm going to write x squared plus 1. That's this guy right here. And then this one I'm going to put on the horizontal, so it's 2x squared plus 3x minus 5. And I'm going to draw my grid. Okay, there's a 2 there, and then x squared times x squared is 2 plus 2, that's 4, 2x to the fourth. X squared times, there's a 3, and then x squared times x is x to the third, 2 plus 1 is 3. X squared negative 5 is negative 5x squared. Okay, and then we have 1 here, so everything here is just going to be 2x squared. We're just multiplying it by 1. 3x and negative 5. Okay, so now we have an x to the 4th term, so it's 2x to the 4th. Cross that out. 2x squared, 3x squared is 5x squared. Cross that out. X to the 3x. Oh, whoops. I blew it. Got to be careful. Remember I told you it's not always perfect diagonals, and it's not in this case. So there's only one x to the 3rd term. That's 3x to the 3rd, okay? And it's positive, so it's plus 3x to the 3rd. Yeah, so you don't just assume it's diagonals, and there I did it, and that was bad. That was a mistake. Now it's 2x squared and minus 5x squared, so 2 minus 5 is negative 3x squared. So now I can cross this out, and that one. And then you have just 3x. And then you have minus 5. And that should have been x to the 3rd. Sorry. Hope you caught that. It's this guy. There was nothing to add this guy to. So it's 3x to the 3rd. So standard form 4, 3, 2, 1, 0 right there. Okay, so that is this area. 2x to the 4th plus 3x to the 3rd minus 3x squared plus 3x minus 5. Okay, so now if you want the area of this entire thing, you got to add this and this. So now it's an addition problem. My highest exponent is 4, so I'm going to come down here and make an x to the 4th column, an x to the 3rd, x squared, x, and then the constant. So in the x to the 4th, again, I'm adding this and this. So it's 2x to the 4th, x to the 3rd. I have 3x to the 3rd here, minus 3x squared, and be sure everything's lined up with its column, plus 3x minus 5. And for this guy, there's no x to the 4th term, so you can just put your little circle there, your little magic circle where nothing goes. Then it's 2x to the 3rd plus 6x squared. There's no x term here, so again we're going to have a little invisible nothing there. Let me get on screen better. And then minus 4. And now you simply add to get your final answer. This plus this. So it's 2x to the 4th. 3 plus 2 is 5. 5x to the 3rd. Negative 3 plus 6 is positive 3x squared. 3x plus 0 is plus 3x. And negative 5 plus negative 4 is negative 9. And that is your final answer. That's the area. Okay, that's everything inside of all of this right there. That's the area. Okay, to do the perimeter, well, I tell you what, I am going to... I'm not going to do that. I'm just going to leave that for you to do. You're going to add this plus this plus this minus this plus this plus this plus this. I'm going to go ahead and do that. All right, because I'm your teacher and I'm going to do all that for you. Okay, so I'm going to cover this up because I need the space. And I'm going to put a piece of paper over here so you can see all that at the same time. And it's still going to be hard to do it right, but I'll have to move the paper back and forth. So here we go. I'm going to start here. 2x squared plus 3x plus 5. We want to know the distance around. We're going to have to add all these things together. It's a big mess. 2x squared (2x squared plus 3x minus 5, so that's this. Then I have to add this. I'm going to put it in parentheses so I keep them separate. Plus x squared plus 1. Okay, and I'm about to go off the screen. Now what I have to do is I have to add this and then subtract this. But notice that this is the same as this. That's originally what we did because we wanted to figure out what this was, right? So why subtract it and add it back again? So I'm going to just add, well, let me do it because it's the way I want you to think the problem through the way you're seeing it. So it's this minus this, so I'm going to come over here and let me try to keep as much on the screen as possible. Plus 2x squared plus 3x minus 5, and then minus this. Okay, again, why is that? Because we said the only way we could know what this side was, and we need to add this to get the perimeter, is to take this side and subtract this side, and that would give us that. So that's what this whole big mess is right there. Okay, so we had to write that. Here we go. I'm going to have to go down to a second line here. Now I'm done with this. That was this part right here. Now I'm here, 2x plus 2, so I'm going to come down to the next line. Plus this side. And finally, plus this side down here, which we said was this plus this. Okay. So it's going to be x squared plus 1, and I'm off screen, I'm sorry, plus, plus 2x plus 2. Okay. That's pretty ugly. There will be one simplification we can do here in a second, but let's just go through this again. We needed to add the perimeter, every one of these sides together. So here is this one. Here is this one. Here is this one, is all of this right there. That's that. That's this side. Then we're ready to add this side. That's this right here. This side, that's this right here, and finally this bottom side, which has two binomials to it, and that's all of that right there. So that's everything all the way around. Now there's one quick simplification we can do. We have minus x squared plus 2x minus 2 and plus x squared plus 2x minus 2. So what we can do is just scratch those right away. Get rid of them. We don't have to add it in and then subtract it back out again. That just makes life more difficult. But the rest of it, unfortunately, there's no easy simplifications for it. So what we're going to do is, it's an addition problem, okay? So what we're going to do is we're going to make our columns, and the biggest exponent we have in any of these, you'll notice, is an x squared. So we only need 3 columns, x squared, x, and then the constant. So let's put all the x squareds under the x squared column. So I'm going to underline them as I go along rather than x them out. So there's 2x squared right there. There's an x squared right there. These are all additions. There's a 2x squared right there. Come down here. There's an x squared right there. And that's everything for x squareds. Now we're ready for the x's. There's 3x right there. I'm going to put a plus sign to be sure that's clear. All the x squareds were positives. Okay. Next is there's another 3x. Come down, there's a 2x. Come over here, and there's a 2x. And that takes care of all the x squareds. The only thing I should have left are constants, things that don't have any x. So there's a negative 5. There's a plus 1. There's another negative 5. There's a plus 2. There's a plus 1. And there's a plus 2. It doesn't matter that this column has more than the other two. It doesn't matter. It just happened to have more of those terms. So let's go through, be sure that everything is underlined, that we've covered everything. And we have. So now we can add. And it's 2x squared plus x squared is 3x squared plus 2x squared is 5x squared plus x squared is 6x squared. 3 plus 3 is 6 plus 2 more is 10. 3 plus 3 plus 2 plus 2 is 10 plus 10x. And this one is negative 5. Let's do the positives first. 1 plus 2 is 3 plus 1 is 4 plus 2 is 6. And then you have a negative 5. Negative 5 is negative 10. So it's 6 minus 10. Again, don't try to do this in your head. Do it on a calculator. So it's 6 minus 10 is going to be negative 4. And that is your answer. That's the perimeter. And you say, what does that mean? It doesn't mean anything. It's just an algebra problem. It means you could make, what it means is you could make a swimming pool of various dimensions, and if somebody told you that they wanted this side to be 10 feet, all of a sudden you would know how to scale all the other sides so you'd have exactly this shape. If they told you they wanted it to be even bigger, they wanted this side to be 20 feet, then you could scale it to make all the other sides bigger. Anyway, that's the perimeter. That's the distance around, okay? Okay, there you go. That's the end. That's all I'm going to do. The rest of them you do on your own. Whoa. The rest of them you do on your own. And that's it. So I'll see you in class, and we'll work some of these in class as well. Let me be sure you saw that. That's area. You saw perimeter. And we're done. Okay, you have a good day.